Welcome, everyone. Today, we are exploring how to design a robust AI strategy for business solutions by implementing the AI adoption process from the Cloud Adoption Framework for Azure. Welcome, everyone. When designing an overarching AI strategy for business solutions, your primary focus must be implementing the AI adoption process defined by the Cloud Adoption Framework, or CAF, for Azure. But what exactly is this framework? Essentially, CAF provides a structured, end-to-end backbone for deploying AI solutions securely and scalably on Azure. The basics involve taking this traditional cloud framework and layering it seamlessly with the specific AI agent lifecycle. Why do we do this? Because building AI agents introduces new complexities around reasoning, data access, and orchestration that traditional software does not face. How do we start? By aligning the 6 core phases of CAF strategy: plan, ready, govern, secure, and manage directly to the 4 stages of the agent lifecycle: plan, govern, and secure, build, and operate. This unified model is critical. Without it, you risk disjointed architectures and fragmented data. Throughout this presentation, we will deep dive into each of these intersection points so you can confidently design an enterprise-ready operating model. We will cover the what, the why, the how, and the when for adopting this framework successfully. Let's examine the diagram on your screen. This visual represents the foundational unification of our 2 primary frameworks. On the left side, you see the Cloud Adoption Framework for AI, which provides the strategic and infrastructural backbone for your cloud environment. On the right side, we have the AI Agent Lifecycle, which governs the specific creation and management of intelligent agents. Notice how these 2 distinct pathways converge in the center to form a single, unified AI operating model. This convergence is the critical concept. By mapping the CAF phases directly to the agent lifecycle stages, we ensure that infrastructural readiness and agent-specific governance are inextricably linked. The final node at the bottom represents the ultimate outcome: enterprise-ready AI agents. This diagram highlights that building AI agents is not a standalone software development task. It is deeply embedded in your organization's broader cloud and security strategy. When these 2 frameworks work in harmony, you build agents that are not only highly capable, but also inherently secure, governed, and perfectly aligned with your Azure environment. Let us explore the why and when of unifying the Cloud Adoption Framework with the AI agent lifecycle. Why is this integration an absolute necessity for your business strategy? If you deploy agents in silos without a unified framework, your organization will almost certainly face agent sprawl. This is where overlapping, ungoverned AI agents consume excessive resources, expose sensitive data, and create massive operational overhead. By aligning the CAF with the agent lifecycle, you establish stringent operational guardrails. You bring order to chaos. When should you apply this? This framework must be initiated at the very beginning of your AI journey, well before any proof of concept moves into production. How does this mitigate risk? It ensures that every agent is bound by enterprise security policies, operates within defined landing zones, and relies only on authoritative data sources. The deep dive here reveals that integrating these frameworks accelerates your time to value. Your development teams no longer have to guess about security baselines or deployment standards because the unified model provides a repeatable, secure, and highly scalable pathway for all AI initiatives. Taking a look at this flowchart, we break down the specific risks and challenges that the unified adoption process is designed to mitigate. At the top, we have the core challenge: AI adoption without governance. From there, the diagram branches into 3 major risk categories that plague unstructured AI deployments. The first branch shows agent sprawl, which occurs when multiple teams build redundant agents, leading to wasted resources and confusion. The middle branch highlights security vulnerabilities, representing the severe risks of data leakage and non-compliant access when agents operate outside enterprise guardrails. The third branch points to disconnected data, where AI models provide poor or hallucinated answers because they lack access to authoritative, centralized data estates. Finally, notice how all these negative branches flow into the bottom node, the unified CAF and agent lifecycle strategy. This demonstrates how applying our structured framework systematically resolves these issues. It replaces sprawl with managed portfolios, vulnerabilities with hardened security, and disconnected data with unified, grounded knowledge sources. Moving to our first major phase, we align the CAF strategy and plan stages with the plan agent stage of the agent lifecycle. What happens here? This is where you translate abstract business goals into an actionable AI adoption plan. The how involves starting with a clear identification of high-impact use cases and defining measurable success metrics or ROI hypotheses. You must answer a critical architectural question early on. Should we use a ready-made SaaS agent like Microsoft 365 Copilot, or build a custom pro-code agent using Microsoft Foundry? This technology decision tree forms your agent technology plan. Why is this critical? Because choosing the wrong platform leads to technical debt and missed business outcomes. You will also conduct a thorough skills assessment to identify any gaps in your engineering or data teams. During this phase, you run your initial proofs of concept, or PCS. A deep dive into this stage emphasizes data readiness and identity modeling. You are not just planning the agent's functionality, you are verifying that the grounding data is available and that the organization is ready to support the AI workload securely. Focus your attention on this process flow, which illustrates the strategy and planning phase in action. The journey begins at the top with defined business outcomes. This is where you establish the measurable ROI and specific goals for your AI initiative. This flows directly into the assess use cases and skills node, where you evaluate both the technical feasibility of the proposed solutions and the readiness of your development teams. From there, the path leads to a critical decision gateway, the agent technology decision. Here, you must choose the appropriate platform. The diagram splits into two options. On one side, we have SaaS agents, such as Microsoft 365 Copilot, which are ideal for rapid deployment and standard productivity tasks. On the other side, we have custom agents utilizing Copilot Studio or Microsoft Foundry, which are necessary for complex, highly specialized enterprise workflows. Finally, regardless of the technology chosen, both paths converge at the run proof of concept node. This visual reinforces that all strategic planning and technology selection must culminate in a validated, tightly scoped POC before any large-scale development begins. Now we enter the ready phase of the cloud adoption framework, which aligns with establishing the foundation for govern and secure agents. What is the core objective here? It is to build the actual Azure environment where your AI will securely live. How do we achieve this? By deploying Azure Enterprise Landing Zones. These are pre-configured, scalable multi-account environments that provide foundational networking, identity, and security scaffolding. Why do we need them? Landing zones isolate your AI workloads, separating internal experimental data from external, customer-facing applications. The basics of this phase also require preparing your data estate. An agent is only as good as the data it is grounded on. Therefore, you must establish authoritative data sources and define strict data access models. In our deep dive, we focus on network segmentation and policy assignments. You are constructing boundaries that dictate exactly what an agent can see and interact with. When this phase is complete, your infrastructure is fully prepared to host intelligent agents without compromising your enterprise security posture or regulatory compliance requirements. This architectural diagram provides a high-level view of the AI-ready phase, focusing on the concept of Azure Enterprise Landing Zones. At the top of the hierarchy, we see the overarching Azure Enterprise Landing Zone. This represents your secure, governed cloud boundary. Inside this boundary, the architecture is segmented into specialized management groups. On the left, we have the data estate, which houses your organization's authoritative, curated data sources, the lifeblood of any accurate AI agent. On the right, we have the AI application environments, where the actual compute and orchestration happen. Within this application environment, the diagram further specifies your development platforms, such as Copilot Studio and Azure AI Foundry. The arrows connecting the data estate to the AI application environments illustrate the secure, governed data access pathways. This setup ensures that your agents can retrieve the necessary enterprise knowledge without violating security policies. This visualization emphasizes that before you build your agents, you must first construct a segmented, secure, and highly organized infrastructural foundation. Welcome to the enforcement phase. Here we merge the CAF govern and secure phases with the ongoing govern and secure agents lifecycle stage. What are we doing? We are transitioning from defining policies to actively enforcing them across the AI estate. How do we execute this? We apply policy-based governance using Azure Policy and Platform Baselines to manage organizational risk. Why is this so crucial? Because AI agents can autonomously retrieve data and execute actions. Without strict enforcement of data loss prevention, or DLP, and role-based access controls, the risk of data exfiltration or unintended actions skyrockets. The basics include implementing controls for agent behavior, reviewing prompts, securing model endpoints, and establishing comprehensive audit trails. A deep dive into this topic reveals the necessity of continuous threat protection and identity governance. Every agent, tool, and pipeline must have a unique managed identity with least privilege access. When you enforce these governance models, you ensure that every AI action remains transparent, auditable, and firmly within the ethical and security boundaries of your enterprise. Let us walk through this governance and security flowchart, which maps out the enforcement mechanisms critical to deploying responsible AI. The process initiates at the agent request node, representing a user or system attempting to invoke an AI action. Immediately, the request hits the first line of defense, identity and access control, or RBAC. Here, the system verifies the managed identity and ensures the principles of least privilege are upheld. If authorized, the flow proceeds to the data loss prevention, or DLP node. This is a crucial guardrail where the system scans for sensitive information and ensures compliance with data residency and classification policies. Once the data passes DLP checks, it moves to content safety and threat protection, which filters out prompt injections, malicious inputs, and toxic content. Finally, the approved and sanitized action reaches the audit logging and execution phase. This diagram clearly illustrates a defense-in-depth strategy. It shows that an AI agent's action is never direct. It must successfully navigate a gauntlet of automated security and governance gates to ensure enterprise safety. With our governance enforced, we transition to the build phase. Here, the agent lifecycle takes center stage, supported by the foundational readiness of Azure. What is the main goal? To standardize the process of building agents consistently across all development teams. Why do we standardize? To prevent architecture drift, avoid duplicated efforts, and eliminate security gaps that occur when developers create isolated, shadow AI projects. How is this achieved? By establishing standard agent templates, utilizing continuous integration and continuous deployment, or CI/CD pipelines, and adhering strictly to Microsoft's reference architectures. The basics of building involve selecting the right platform services, whether that is Copilot Studio for low-code workflows or Microsoft Foundry for complex, pro-code orchestrations. Our deep dive here emphasizes the implementation of evaluation gates. Before an agent is promoted from development to testing, it must pass rigorous functional, safety, and guardrail checks. You are creating a software development lifecycle specifically tailored for AI, ensuring that every agent deployed is robust, reliable, and entirely secure. This diagram illustrates the standardized software development lifecycle, or SDLC, specifically adapted for building AI agents. The sequence begins on the left with develop agent logic and prompts. This is where makers use Copilot Studio or Foundry to author the agent's core behaviors and integrations. From development, the arrow moves to offline evaluation and testing. This is a vital step where the agent is subjected to automated tests, edge case scenarios, and safety validations using curated datasets. It ensures the model behaves predictably. Next, the flow hits a critical promotion gate. This represents the formal approval process, often involving security and compliance reviews required before an agent can be moved out of the development environment. Once approved, the agent proceeds to deploy via CI/CD, utilizing automated pipelines to ensure a consistent, error-free rollout. This visual underscores the importance of a rigorous, repeatable build process. It demonstrates that building enterprise AI is not a free-for-all, but a highly structured progression designed to catch errors and enforce quality long before the agent reaches your end users. Finally, we reach the deployment and operational phase. We align the CAF manage phase with the operate agent's lifecycle stage. What does it mean to operate an AI agent? It means transitioning the workload into a live production environment and maintaining its health. How do we do this? By defining strict deployment authorities, implementing comprehensive monitoring, and establishing service-level objectives, or SLOs. Why is this phase indispensable? Because AI models and agents degrade over time if left unmonitored, data drifts, and user expectations evolve. The basics require you to establish centralized telemetry to monitor latency, token consumption, error rates, and guardrail triggers. In our deep dive, we focus on the feedback loop of continuous improvement. You must analyze the telemetry to optimize costs and tune the agent's performance dynamically. Furthermore, you must prepare incident response rubbooks. If an agent hallucinates or accesses restricted data, your operations team must know exactly how to disable it safely, preserve the audit logs, and remediate the issue without disrupting broader business operations. Take a moment to review this continuous feedback loop, which represents the management and operations phase of the agent lifecycle. Unlike traditional linear deployment, AI operations are cyclical. The cycle starts at the top with deploy and serve agent, where the agent actively handles user requests in production. Immediately, this feeds into the collect telemetry and logs node. Here, the system continuously gathers data on token usage, latency, error rates, and user feedback. This raw data flows into the analyze performance and drift stage, where operations teams look for degradation in model accuracy or shifts in user behavior. Based on these insights, the process moves to tune prompts and grounding data. This is where architects and developers refine instructions and update knowledge sources to improve agent quality. Finally, the tuned agent is pushed back to the deployment stage, closing the loop. This diagram beautifully illustrates that launching an AI agent is only the beginning. Maintaining a high-quality AI solution requires a relentless, data-driven cycle of monitoring, analysis, and continuous optimization to adapt to changing business needs. In our final slide, we synthesize the entire strategy into actionable execution using checklists and RACI alignment. What is the ultimate takeaway? Implementing the AI adoption process from the Cloud Adoption Framework is not just theoretical, it requires disciplined, step-by-step validation. How do we ensure success? By utilizing readiness checklists before moving any agent from a proof of concept into full production. Why rely on these checklists? They guarantee that no critical requirement, be it data privacy, security, ROI measurement, or compliance, is overlooked. The basics of this transition also involve aligning your teams using a RACI matrix, which defines who is responsible, accountable, consulted, and informed for every activity. Our deep dive emphasizes that the solution architect must orchestrate this alignment across platform, security, and data teams. When you combine the robust Azure infrastructure from CAF with the specialized governance of the AI agent lifecycle, you empower your organization to innovate rapidly. You establish an enterprise-ready operating model that delivers secure, scalable, and highly impactful AI business solutions. Our final diagram presents a matrix-style flowchart showing the alignment of the RACI model with the transition from proof of concept to production. On the left side, we have the key personas, the solution architect, the security team, and the data owner. These roles feed into the central transition pipeline. The pipeline starts with the POC validation checklist, where the initial agent prototype is measured against the predefined success criteria. Once validated, the process moves to the security and compliance sign-off node, ensuring that the security team has approved the data access boundaries and threat protections. Next is the data readiness confirmation, requiring the data owner to certify that the grounding data is authoritative and highly available for production loads. Finally, all these collaborative approvals culminate in production rollout. This visual highlights the collaborative nature of enterprise AI. It shows that moving an agent to production is not solely an engineering task. It requires synchronized accountability across architecture, security, and data governance to ensure a safe, scalable, and successful enterprise deployment.